Alrighty guys, so today we're going to be going over the review for the second quiz for this class. Now before we get started, let me just go over what's going to be on the quiz. So there's going to be three basic things that you're going to need to know, and I've written them down right here. So first thing you're going to need to know is about ion charges. So can you calculate if it's +1, +2? What does it mean with the protons and electrons? How do you determine that? So that's what you're going to need to know. Just one thing you should keep in mind that's really important is that the charge is equal to the protons minus electrons, and that's going to help you figure out the ion charge. Secondly, you're going to need to know how two ions will react with one another. So are they going to attract, come closer together? Are they going to repel, go apart? Or are they not going to do anything? So the key thing to remember here is that opposites attract. So if they're opposite charges, positive and negative, they'll attract. And the same charges repel. Okay, so if they're the same charge, if it's positive, positive, they're going to repel. And if they're negative, negative, they're going to repel. And there's going to be no reaction if one of the atoms is neutral. Okay, so just make sure you keep that in mind. And then lastly, drawing the shell models and the Lewis structures, the one that we learned last time. So for the Lewis structures, we only draw the valence or the outside electrons. Okay, so those are the three general things that you're going to have to know, and we're going to be combining all those things together in one problem. So what we're going to do today is we're going to be doing only two problems, and each of the problems shows you the problem you're going to get on the quiz. So for example, we have number 1 right here. Number 1, there's a lot of different parts, A, B, C, D, and so on. That's going to be basically your quiz question. Your quiz is only going to be one problem, but there's going to be multiple parts. So just make sure that you're following along, because basically what I'm going to do today is go over how to do one of your quiz problems. Alright, so let's start with your problem. So when you guys do your quiz problem, you're going to see just some information in the beginning, and it's going to be looking like this. So atom number 1 has 13 protons and 10 electrons, and atom number 2 is going to have 9 protons and 10 electrons. So when you guys do your assignment today and the quiz, I'm basically going to tell you, hey, there's 2 atoms, and I'm going to tell you how many protons and electrons there are for both of them. So the first thing we want to do is figure out which atoms these are. What is atom number 1 and what is atom number 2? And so we're going to calculate that or figure all that stuff out right now. So it's going to ask you first to write the ion symbol. Okay, so we're going to write the ion symbol for atom number 1. Now we have some information right here, so I'm just going to copy that down so we have that to refer to. Atom number 1 has 13 protons and 10 electrons. Okay, so we got to figure out what element it is. So what we're going to do is we're going to go on the periodic table and look for the atom that has 13 protons. So if you guys go across the periodic table, by now you guys should know that protons are going to be based off the atomic number. So the number on the top tells you how many protons there are. So we look for the number 13, and it looks like the element that has 13 protons is aluminum. And the symbol is Al. So I'm going to write Al. I'm going to write it a little bit more to the side. So the symbol is going to be Al. Okay, but we also need to know the charge, because if you notice, the protons and the electrons are not equal, right? They're unequal. If they're unequal, it's not going to be neutral. It's not going to have no charge. There's going to be a charge. So what we're going to do is we're going to use this formula up here. So we're going to write charge is equal to the protons. We have 13 protons minus the electrons, and we have 10 electrons. So you guys can do 13 minus 10. 13 minus 10 is going to be 3, and it's a positive number. So that means the charge is going to be 3 plus. So our first atom, atom number 1, is going to be Al 3 plus. That's going to be the answer to that part right there. Okay? Alright, if you guys think you can do atom number 2 on your own, go ahead and do so. but I'll go through it step by step with the rest of us. Okay, so for atom number 2, we're going to do the exact same thing. We're just going to write down the information we have. It says atom number 2 right here has 9 protons and 10 electrons. So I'm going to write down 9 protons and 10 electrons. Okay, so what we're going to do is we're going to go on the periodic table and look for the atom that has 9 protons. It should be the atom or the element with the 9 on the top. And it looks like it's right here. So the element that has 9 protons is fluorine. Okay, and the symbol is F. Alright, but again, these are unequal, right? It's not 10 and 10, 9 and 9. These are unequal. That means we have to calculate the charge. So for the charge, all we're going to do is plug into this formula up here. We're going to plug in 9 protons minus 10 electrons. 9 minus 10 should give you -1. That means the charge for this atom, for atom number 2, is going to be -1. And I'm just going to put a minus sign. Okay, so we have our 2 atoms now. Atom number 1 is Al3+. Atom number 2 is F-. So for the next part, part C, will they attract or repel? So if you guys notice, this one is +3. This one is -1. It's +3 and -1. So if they're positive and negative, are they going to attract or are they going to repel? Okay, hopefully you said that they attract. Okay, since it's Al3+, right, this one is positive, and F-, this is negative. Positive and negative is going to attract because opposites attract. So for part C, all we need to put is that they attract. Alright, so we're going to move on now to the next parts of the question. We're not done with this problem yet. The next question is how many of each atom is needed to neutralize both? So we said that we have Al3+ and we have F-. Okay, so how many, the question is asking how many Al3+ do you need and how many F- do you need for them to basically balance each other out, to get to no charge, to get to 0 charge. Okay, and this part's really simple. All we need to do is just figure out which one has more energy, positive or negative, and just try to balance that out. So if you look at the numbers, Al is 3+. It's +3, right? And F is just negative. It's -1. So which one has more electrical energy, the positive or the negative? Okay, hopefully you said that the positive has more energy, right? This is more because the number is bigger. It's 3 versus 1. So that means we're going to have to add a little bit more negative in order to balance it out. So if I add another negative, F-, okay, how much negative energy do I have? I have -1 and -1. If you put those two together, you have -2. Okay, but if you notice, it's still +3 versus -2. It's still not balanced out. And so what we need to do is we need to add another F, right? Because if I have another F, how much negative energy do I have? I have -1, -2, -3. And so if I have +3 and -3, they can finally balance each other out to 0. So how many do you need of each atom to neutralize it? How many ALs do we have? We have 1. So you would just write, you would need 1 Al3+. Make sure you don't forget the charge. If you just write Al, it's going to be incorrect because Al is not the same thing as Al3+. Okay, and how many Fs did you use? I used 3. And make sure, again, you put F-. So this is how you would answer this problem. I know a lot of people got this problem wrong on the assignment when we did it. So just make sure you guys check your responses on Canvas, the assignment that you turned in, just to make sure you set it up like this. You should have an answer that looks very similar to that. All right, so we figured out how many you need to neutralize one another. Now we can move on to some drawings. Okay, so the first thing that we're going to do is we're going to draw the shell model for atom number 1. We said atom number 1 is Al3+, and then we're going to draw the shell model for F-. So let's start with Al3+. Okay, so in order to draw the shell model, we first need to figure out, obviously, how many shells does our atom have. Okay, so if you look at the number of shells that Al is going to have, so we're looking at Al right now. How many shells does it have? So the number of shells is equal to the row number. Okay, so if you notice, there's row number 1, row number 2, and then there's row number 3. So Al is on the 3rd row, so that means it's going to have 3 shells. Okay, so regular Al is going to have 3 shells. Okay, and then we said earlier that the number of protons that Al3+ has is 13 protons. You guys can get this information from the top. And we said Al3+ has 10 electrons. So what I'm going to do is I'm going to draw Al. Okay, Al3+, don't forget the charge, and I'm going to draw 3 shells. Okay, so we're going to draw 3 shells, 1, 2, 3, because it's on the 3rd row. Okay, and all we need to do now is we just need to fill in the shells, and we always want to start from the inside out, okay? But before we do that, we need to keep one thing in mind, and the thing that we need to keep in mind is how many electrons, how many dots can we draw in each shell? So if you guys remember, the number of boxes in the row tells us how many electrons we can draw. So if you look at this first row right here, okay, how many boxes are there? There's 1, and then there's 2. So that means that the first row, the first shell, it can have 2 electrons max, right? Because there's 1 box, 2 box. Okay, what about the second shell? We can get that by looking at the second row. There's 1, 2, 3, 4, 5, 6, 7, 8. So if there's 8 boxes, it can hold 8 electrons max. And then the third row has 1, 2, 3, 4, 5, 6, 7, 8. So the third row, the third shell, can also hold 8 electrons max. And we'll stop right there because we said Al has 3 shells. Okay, so now we know the maximum number of electrons that go in each shell, so we can start drawing those out. So if we start with we always want to start from the inside out. Okay, so we have 10 electrons, so let's draw them. We're going to draw 1, we're going to draw 2. But once we draw the 2, we can't put any more in the first shell, right? Because the first shell can only hold 2 electrons. Okay, so we're done with that one. Now we got to move on to the second shell. So we did 2, so we're going to go 3, 4, 5, 6, 7, 8, 9, 10. And we've used up all of our electrons. We have 2 in the first shell. The first shell has 2 electrons, and the second shell has 8. And we're good because the second shell can only hold 8. Okay, and we've used up all 10. Okay, so now we have a problem, right? Because we filled up the first 2 shells, and we always want to start from the inside out. But if you look at this third shell, there's no electrons, right? There's nothing there. And so if you guys remember from your notes, if there's no shell or no electrons, that means there's no shell. So since the third shell had no electrons in it, that third shell doesn't exist. It's not a real thing. And so that means that Al3+ doesn't have 3 shells, it has 2 shells. And since Al3+ has 2 shells, this is going to be it. This is going to be our shell model. Okay? Alright, so moving on, we can do the exact same thing for F minus. Okay, we said that earlier, F minus has 9 protons and it has 10 electrons, and this information came from the directions. Okay, so if we look at F on the periodic table, which row is F on? How many shells does F have? Okay, you should notice that F is on the second row, right? Because it's row number 1 and then row number 2. It's on the second row. So that means regular F has 2 shells. So I'm going to draw F minus and I'm going to draw 2 shells. Alright, and all we have to do is fill in the electrons now. If you remember, we always want to start from the inside out, and remember that the first shell can only hold 2, the second shell can only hold 8. So we're going to start with the beginning. So we're going to go 1, 2, and so that shell is filled up. 3, 4, 5, 6, 7, 8, 9, 10. And so if we look at the first shell, how many electrons on there? There's 1, there's 2. There's 2 electrons. The second shell has 1, 2, 3, 4, 5, 6, 7, 8. So that second shell is full as well. So 2 plus 8 is going to give you 10. So we've used up all the electrons, and now all the shells are full, and we're good to go. So that means that Al3 plus has 2 shells with 10 electrons, and F minus has the same one. So they're going to look very identical. The only difference is the middle with the number of protons. That's the only difference between the two. Alrighty, so that's how you draw the shell models. And then last but not least, we're going to draw the Lewis structure. For the Lewis structure, all we need to do is draw something called the valence electrons. Okay, and we said that the valence electrons are the outside electrons. The electrons on the outside. Okay, so if we look at the outside of Al3+, we just count. There's 1, 2, 3, 4, 5, 6, 7, 8. So for the Lewis structure, all we need to write is Al3+, and we just need to draw 1, 2, 3, 4, 5, 6, 7, 8. And there you go. That's the Lewis structure for Al3+. We basically just copied this, but all we did was we took out the inside shell. We just draw the outside shell. That is what that's what a Lewis structure is. A Lewis structure is just drawing the electrons on the outside. Okay, we can do the same thing for F minus. So we can draw F minus and we just count the electrons on the valence or the outside shell. And if we look on the outside shell, there's also 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, and that's it. That's what your quiz is going to look like. That's one quiz problem, and your quiz is only going to be one question. If you can do all those things, then you should be totally fine. Alrighty, so what we're going to do now is we're going to just do one more problem on the video just so that you guys have a little bit more exposure to this. If you feel pretty confident, you can just try this problem out on your own. You can pause the video here, try out the quiz problem. That way you can be pretty confident that you're able to do the quiz, and then after that you can move on to the quiz review assignment. But I'm going to take it step by step because I know that some people are still figuring it out, and there's no problem with that. I'm here to take it step by step with you. Alright, so let's start. So same thing as last time. It tells us that atom number 1 has 4 protons, 2 electrons. Atom number 2 has 15 protons, 18 electrons. So we're going to start off by figuring out which elements these atoms are. So let's start with atom number 1. So for atom number 1, what we're going to do is we're just going to look up how to, we're just going to look up the protons. So atom number 1 has 4 protons. So atom number 1 has 4 protons and 2 electrons. Now the element is determined by the proton. So we just go on the periodic table and look for the number 4 on top. You should find number 4 right here. The number on the top is the proton. So we know that atom number 1 is beryllium. The symbol is Be. Okay, so atom number 1 is beryllium. But if you notice, the protons and the electrons are not the same, so that means we need to find the charge. And we know that the charge is equal to the protons minus the electrons. So we just plug and chug into this equation. 4 minus 2 is going to give us positive 2. Okay, so that means that this ion is Be2+, beryllium 2+. Alright, the second atom, it's up here. It has 15 protons and 18 electrons. And we're going to calculate the charge. Okay, and the charge is going to be protons, so 15 minus electrons, 18. So 15 minus 18 is -3. Okay, so the charge is -3. And I forgot to find the atom, but it's okay. Because since it's 15 protons, we just look for the element with 15 on the top. Should be right here. And the element that has 15 on the top is phosphorus. It's P. So we're going to write P. And we know that the charge is -3, so the charge is going to be 3 minus. So P3 minus. Okay, so our atom number 1 is Be2+. Atom number 2 is P3 minus. And are they going to attract or repel? It looks like atom number 1 is positive. Atom number 2 is negative. So since they're opposite, we know that they're going to attract. Alrighty, so now we need to figure out how many of each atom we need to neutralize both. So if you guys notice, Be is 2+ and P is 3 minus. And so we want to figure out how we can balance these out so that they can go to 0. So if you guys notice, +2, -3, which one is a bigger number? -3, right? -3 is, there's more negative energy. So that means I'm going to have to add another Be2+ in order to balance that out. Okay, because the charges, if we just go back and put it together. So the charge here is +2, and the charge here is -3. So what we're going to do is we're going to add another Be2+. That way we can get a little bit more positive charge. But if I add another 2+, 2 plus 2 is... It's no longer +2 anymore. It's +4. Okay, now we have another problem because now it's too much positive energy. So what we're going to have to do now is we're going to have to add another source of negative energy. So P3 minus. Okay, because +4 is bigger than -3, so we're going to have to add the same thing in order to balance it out. The problem now is -3 minus 3 is not -3 anymore. It's going to be -6. So it's too negative now. It's more negative energy. So what we have to do now is add another Be2+, because that way we can get 2 plus 2 plus 2, which will give us +6. And if you notice, it's +6, -6. These can balance each other out to give us 0. Okay, so how many of each atom did we use? There's 1, 2, 3 Be2+, and we used 1, 2 P3 minus. And so there you go. That's how many of each we need to balance out the atoms. Alrighty guys, so now what we're going to do is we're going to draw the shell model. So I'm going to draw the shell model for atom number 1 and then the shell model for atom number 2. So we said that atom number 1 is Be2+, and atom number 2 is P3 minus. Okay, so we know that Be2+, it has 4 protons and 2 electrons, and atom number 2 has 15 protons and 18 electrons. And we got these numbers from the top. Okay, so let's start with Be2+. If you guys notice, Be, we need to figure out how many shells it's going to have. So in order to look at the shells, we need to look at the rows. So this is row number 1. This is row number 2. BE is on the second row, so BE has 2 shells. Okay, so we can draw BE and draw 2 shells. And we're going to fill them in from the inside out. Now, if you guys remember from earlier, the first shell is the first row. So the first row has 1 box, 2 box. Since there's 2 boxes, it can hold 2 electrons max. The second shell, since it has 1, 2, 3, 4, 5, 6, 7, 8 boxes, it can hold 8 electrons max. And so what we're going to do is we're going to take the shells and we're going to draw the electrons into the shell, starting from the inside out. So if we look at BE, BE has 2 electrons, and the first shell can hold 2 electrons max. So we're going to draw 1, 2 electrons. Okay, but the problem is we ran out of electrons, and if you look at this second shell, it's completely empty. And if there's an empty shell, that shell does not exist. So that means we can just get rid of that second shell. And so this is going to be our shell model. So BE, I forgot to write the charge. BE2 plus, BE has 2 shells, but BE2 plus only has 1 shell because that second shell disappeared. Alright, moving on to the next one, P3 minus. If we look at P3 minus, it's on row number 1, 2, 3. It's on the third row. So that means if it's on the third row, it's going to have 3 shells. So P has 3 shells. Okay, and we know that the first shell holds 2, the second shell holds 8, and the third shell also holds 8. Because there's 1, 2, 3, 4, 5, 6, 7, 8 boxes. Alright, so let's draw P3 minus. So I'm going to write P3 minus. I'm going to draw 3 shells around it. 1, 2, and 3. Alright, so what we're going to do is we're going to draw the electrons and we're going to start from the inside out. So I'm going to draw, so on the first shell, I'm going to draw 1, 2. So we drew 2 electrons. And we filled up the second shell so we can move on, or the first shell, now we can move on to the second shell. The second shell we have 1, 2, 3, 4, 5, 6, 7, 8. So the second shell, we drew 8 electrons, and that maxed it out. So we've used 2 and 8, so we've used 10. And so for the third shell, we have to draw 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the third shell, we drew 8 electrons. Okay, and just to add it all up to make sure we used up all our electrons, we have 2 plus 8, 10. 10 plus 8 is 18, and this number is the same as this number, so we're good to go. We drew all our electrons. And so we've drawn P3 minus. P3 minus also has 3 shells, and it looks something like this. Okay, and those are the shell models. Alright, so you can't really see it on the screen right now, but we also need to draw the Lewis structures, but I'm going to do it right here just because it's going to be easier to see next to the shell models. Okay, so now we need to draw the Lewis structures. Okay, Lewis structures are very easy. All we do is we take the shell model and then we just draw the electrons on the outside, the valence electron. So if you look at Be2+, the outside shell is the first shell, right? Because if you only have one shell, the outside is going to be the first one. And it looks like there's 2 electrons, so we just draw 1, 2. 2 electrons, and we're good to go. That's the Lewis structure for Be2+. And then P3 minus, we're just going to write P3 minus, and if you notice on the outside shell, the valence shell, there's 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, so these things are basically equal to each other. They're the same thing. And if you notice with the big one, it's a lot easier to draw this than to draw this. Okay, so just keep in mind the Lewis structures, We only draw the valence or the outside electrons. Alrighty guys, so before I let you guys go, I do want to give you guys one trick for drawing Lewis structures. Okay? So one trick for drawing Lewis structures. Let's say, for example, we did that already. So let's say, for example, you are asked to draw the Lewis structures, okay, for a neutral atom. Okay, so if you wanted to draw a Lewis structure for a neutral atom, and what I mean by that is an atom without a charge, so something that has no charge. So if I asked you, hey, draw the Lewis structure for Li, okay, no charge, or draw the Lewis structure for Ne, okay, if you notice there's no charge, or draw the Lewis structure for Br, okay, and if you notice there's no charge. All that you need to do is just count the boxes in the row that they're in, and that's going to give you the Lewis structure. So what do I mean by that? So if you look at Li, right? Li is the first box in this row, right? Rows go side to side. It's the first box. Since it's the first box, for Li, the Lewis structure is just one dot. Okay? And you can check this with the shell model if you want to, but when you have a neutral atom, it's really easy to draw a Lewis structure. All you need to do is figure out how many boxes, which box it's in, and that gives you how many electrons, valence electrons there are. So let's look at neon. Neon is all the way here. But if we just count the boxes to get to neon, so we have box 1 here, box 2, and we skip this, if you guys remember from the previous lecture, we skip this section right here. We have box 3, 4, 5, 6, 7, and it looks like neon is box number 8. So since it's box number 8, we just draw 8 valence electrons. Super easy. If they're neutral, all you need to do is count boxes. So if you look at Br, Br is all the way over here, but if you guys remember, we skip this entire section. Groups 3 through 12, we skip this. Okay, so Br is in this row, row number 4, so we can just count 1, 2, skip, 3, 4, 5, 6. Br is 7, so Br only needs 7 valence electrons, right? Because Li is in box 1, so it has 1 valence electron. Neon is box 8 in its row, right? It's box number 8, so it has 8 valence electrons. And Br is box 7, so it's going to have 7 valence electrons. So just make sure you guys keep that in mind. Drawing the Lewis structures for neutral atoms is really, really easy and really, really simple. All you need to do is count boxes. The only thing you need to remember is that you skip this big section right here. Alrighty guys, so hopefully that was helpful. You guys can work on your quiz review now. Let me know if you guys have any questions, and good luck on quiz number 2. Okay? See you next time.